Thanks everyone. Thanks for bearing with me while I set that up. My name's Jack Rust. I'm a product manager at Papercut, but that doesn't really matter for tonight because I'm here in my capacity as an AI nerd. Um, so this is the things that I learned building an artificial neural network for footy tipping, and in the hope that some of these help you with using machine learning or artificial neural networks yourself. It's a short talk, so I'm not going to go too far into the details. Also, I'm not a dev anymore, so I'm not going to show you any code, but you can find it all on GitHub. I've got the links at the end of it if you do want to play around. Before I get into what I learned, the backstory to this is I went to Swinburne studying robotics and mechatronics, and as a final year project, I built a footy tipping, not a footy tipping bot, a facial recognition bot with a few of my friends. But when we divided up the work, as you do at uni, one of my mates got to work on the artificial neural network, and I got stuck with the data processing side, which was actually pretty interesting. But it wasn't the neural network, which is what I wanted to work on. So at the end of that semester, back when I had the time and energy to do this kind of thing, I decided to build a neural network from scratch in object-oriented Java, because that's what I was using at the time. And I've since ported across to C# and .NET, like all the cool kids. So that's what I'm talking about today. I use that currently for footy tipping. And I'll take you through what I learned in doing that. The basic process that this follows when I'm using this tipping bot, it's pretty simple. I screen scrape a whole bunch of websites for all of their footy data. I save it in a local database. I then pull that out and convert it to a format that the neural network can understand, which is fuzzy Boolean, numbers between 0 and 1. And then I push that into the neural network to train it. And then I give it the latest data so it can tip each round. So the first thing that I've learned, and you can think about if you're thinking of using an artificial neural network, is think about what you're classifying. So neural networks are great at problems of classification. So as a rule of thumb, if you can frame your problem as a problem of classification, then it's a good opportunity to use a neural network. If you can't, then it might not be the right tool for the job. And I learned this the hard way when I first put together the neural network. I was trying to think of a way to test it out because I put it together just for the fun of building it. I hadn't actually had a project in mind. And I tried to test it out on multiplication because I thought, what's the simplest thing for a pattern recognition machine learning solution? I'll teach it the 2 times tables and see if it can learn. But neural networks aren't pattern recognition machines. They're classification machines for the most part. There's variations, and I'm sure someone will pull me up on it. But it was a classification machine that I built, and what it was actually doing, I thought that I was getting it to predict the result of a multiplication problem. What it was actually doing was identifying the bigness of a number. It was classifying it into how big a number it was, which was no good. But I moved on to footy tipping because that was data that I had available. It was top of mind. I was in the footy tipping comp at work. And it turns out that footy tipping is actually a really good use for a neural network. It has all the right attributes to make it a good test case for a network. It's a problem of classification. You're classifying into categories of home team win, away team win, and draw. It has lots of data available. That's one of the most important things for any kind of machine learning is that you've got lots of data at your fingertips. It's all freely available. You can just go and find it. There's a clear result. You know whether you're correct or not. At the end of every match, there's a winner, a loser, or a draw. So you know whether you've gotten the right result. So you can check some and your network can learn from its mistakes. And also something that's a bit underrated in machine learning is you need to take into account the ethical considerations of handing over decision-making to a machine. And I do say that seriously. If you're using a machine, particularly at work, if you're using machine learning, think about what it means to hand over decision-making to a machine. The good thing about footy tipping is it really doesn't matter. This is just for fun and silliness. So it doesn't really matter if my results are biased in some way. If it's biased against Carlton, all the better. So the second thing was from building this, and I did really enjoy building the neural network. I would encourage anyone to have a crack at building something like this yourself. You get a really deep understanding of what's going on under the hood. But that's why you should be building it. You should be building it because it's interesting to you or because you want to understand it better. In 99% of cases, if your work needs a machine learning solution, you probably shouldn't be building one yourself. This is where the product manager in me comes out. There's plenty of good quality neural networks and other machine learning tools available online. Most of them have a pretty decent free tier. So if you need one for work, just use something off the shelf. Don't build one from scratch unless that's what it is that your company does. That said, that's not discouraging you from building a neural network. Definitely do, because they're awesome. They're super cool. And you get a lot more appreciation from building something yourself from scratch. I think of it the same way as people who can build a car themselves. They understand how to look after a car, even if it's not the one they built. And it's the same thing with building a machine learning system. Once you've built it, you have a deeper understanding of what's going on under the hood. That said, if you want to play with my one, it is up on GitHub. I've got links at the end of the presentation so I can share those around. You can go and find it. You can take a screenshot if you want to Google it yourself. It isn't built for other people to look at. I built it just for myself, but it's there. So feel free to peruse it if you're interested. The other thing is I learned how an artificial neural network actually works. So I had this rough idea of a system that learns from the data it's given, but from building it, like I say, you get this deeper understanding of what's going on under the hood. And this is the classic diagram that you see of what a neural network looks like, how it works. And I don't have time to go into it today because this is the appetizer course. So I'll leave the delicious filling mains for the next talk. But from building this, I've learned a lot more about how it works. And the short version of this is I like to think of this as really similar to gossip. The way that it works, each of these individual nodes knows nothing about the world around it. No part of this network knows what football is, what the results of last week were, or anything like that. They're just getting numbers and deciding whether to send the information out. And I think of it a lot like gossip, where you hear all this information from different people, and to begin with, you have no idea about what's true and what isn't, what's good information and what's bad. But over time, you start to learn who's been telling you the wrong thing, who's not been giving you good information, and who has. And so you can adjust over time. Each one of these neurons is adjusting to the information it's being given so it can make better decisions in future. We could always go into that in more detail, but I only have 15 minutes to talk you through it today. So I'll move on from this. If you're interested, more than happy to talk about this more. The fourth thing is probably the biggest. It's all about the data. In machine learning in general, but in artificial neural networks in particular, it's all about the data. And I mean that in two different ways. One thing that I learned from doing this was how much of the data decisions are still made by the humans. So going into this, even at uni when I was working on this project, I sort of had in my head that machine learning was reasonably objective. So you give it, all the data about the system, and then you ask the neural network to use that data to predict whatever the results are, whatever it is you want them to pick, whether it's faces or the winner of the next football match. It should be an objective process to learn from. And maybe you might say that definitely there could be biases in the system itself. So if there's biases, if you're building an applicant shortlisting robot, then certainly if you're building that off the back of how recruiters work today, those recruiters themselves might be biased. So if the system's biased, the machine will inherit it. What I didn't realize until I actually built this and had to start putting the data together for it was how much you need to carefully consider what data you give the network. Because I said before, you give it all the data in the system, but we know as developers, that's not a meaningful thing to say. That's not a helpful requirement. Give it all the data. What data and in what form? Because the neural network can only deal with numbers between 0 and 1. there's some conversion that you can do. There's some of that you can automate. But in the end, you're still making decisions about what data to give it. To a human, I might say, Geelong's been looking good recently. That's the kind of advice I might give a human to help them tip results. But I would be saying that without really thinking about what it means. To a machine, you have to think all the way down to the nth degree. Am I talking about the last 1 match, 5 matches, 10 matches? Am I talking about how much they're winning by or whether they've just won or lost? Am I thinking about which teams they've beat? All of those are decisions that the human needs to make when feeding into the system. So the network itself is going to be limited by the decisions that the human makes about what data to give it. So that's just something to consider about machine learning in general. The other half of data being everything is how much you can do with very little data. So I had to think about this today. There's really only 4 data points that I give my network. The teams that are playing, the ground that they're playing at, the time, and then the score, the result of the game. That's it. And then it's variations on that theme. So out of 4 data points, out of all the different data that's out there, I'm only feeding my network these 4 things at the moment. But back to that humans making decisions about what data the machine uses, I've picked together lots of different combinations of this. So maybe it's whether the teams have shared an opponent in the last 10 weeks, how they've performed at the ground on average and over the last few weeks, and all of these kind of combinations of things. So you can do a lot with a little with data, and it's amazing how accurate an artificial neural network can get with limited context. And that leads me to the last point. You can build a machine that's, well, maybe not smarter than yourself, but performs better at a task than yourself, which, just to think about it for a second, I built all of this. This is, I built the network and the data processing that feeds into it. I have access to all the same data. I have access to much more data than the machine does. I know how the machine works. I can see inside its head, and it still regularly out-tips me. Last season, I competed against it head to head, and it out-tipped me by a full round, more than a round of games. And that's amazing to me that I had all the data it had and more. I could see how it was making decisions. I could see how it was going, and it would still beat me overall in the tipping. And I think that's really cool that we can build a machine that can outperform ourselves, even competing directly head to head against the machine. That's all I have for you tonight. If you want to find me, on the GitHub, you can find the Footy Tipping project, so feel free to have a play if that's what you're interested in. Like I say, I'm not a dev anymore, so don't judge me too harshly. You can find me on Twitter. I mainly use it for posting the bot's tips, and I'm slowly converting the bot into a Twitter bot as well, so maybe it'll start posting for me and I can just automate myself right out of Twitter. And if you're interested, the next round results are there, so you can follow those, and depending on how they do, you can tell me how good the tipping bot is.